Hello, we're Team 4N1K. I'm Arpan Patel.
I'm Aya Assaf.
I'm Elliot Baker.
I'm Drew Boughton.
And I'm Clifford Leveque.
So, with the abilities of industrial robots constantly expanding, more opportunities for automating specialized tasks such as art and painting are attainable. Throughout this semester, we've been asked to design and 3D print a 3D paintbrush holder for the ABB 140 industrial robot. Along with that, we were asked to write code that would be able to produce an intricate drawing. Our design was made in Inventor and was 3D printed using the Cura software. But before we go into the specifics of each part of our project, I just want to quickly go over the agenda. So first we'll go into the calibration of the robot so that the robot knows where the pens actually are. Second thing we'll go over is a video of the actual drawing itself. Third, we'll go over the final assembly of how each part of our project came together on the robot. Then we'll talk about the CAD design of the paintbrush holder and how we 3D printed it through the Cura software. We'll go through the toolpaths and the programming of how we were able to produce a drawing. Then we'll go through some of the issues that we encountered, as well as some potential improvements that can be made in these processes. And then we'll talk about our Gantt chart, which is our timeline of where we were, where we are now, and where we are planning to be in the future. And then we'll talk about the social science aspect of drawing with industrial robots, and then we'll conclude and end our presentation. Next. So first, the calibration of the robot. In order for the robot to actually know where the pens are relative to the robot itself, we had to manually adjust and orient the tool pens according to this one needle. Each pen needed 3 points of contact, which actually took more time than what was expected because we had to do 3 points of contact for each pen. Next. And now I'll pass it on to Clifford to actually go through the video.
Okay, so here we have a video representation of the robot actually completing the entire drawing using both pens. We'll start with the first toolpath with the marker that was supposedly going to be blue, which was our initial idea. During this actual representation, we ended up using a brown marker because the blue ended up drying out due to the way that the pens needed to fit on the robot. The second toolpath uses the gold marker, and it will draw on the paper as well as the second toolpath. And as you can see, these markers didn't end up actually marking the paper because of the way that they dried out as well, and or the way that the tool bed was leveled. So we ended up having a few issues there during this actual physical rendition of the drawing, and we'll go more into the issues later. So here it's going step by step, about to complete the drawing as it should if it had been actually marking the paper. Okay, so our final drawing ended up looking like the image on the left, which is a little bit of the brown that had actually shown up on the paper. And this would be the actual representation of our reference image that we used based on an image we found of a mountainscape online. This is our own rendition to avoid any sort of copyright issues or anything along those lines. But we initially intended it for it to be an entire geometric mountainscape image, and that would be done in blue and gold for our Michigan spirit, of course. But our final drawing ended up looking like the image on the left, which only got a portion of it to actually get drawn down on the paper. But you can tell that it was doing exactly how we wanted it to, and all the lines were in the right places, and they ended up drawing very well. So here we have a description of the assembly once we had all of our parts done and together made out. So first you see the ABB robot arm on top, and we had to attach our 3D printed flange or the robot flange onto that first, and then using another screw, we attached our flange adapter, which is the 3D printed part that we had designed using the Ultimaker 3D printers, and then we attached that to the robot arm. Then we cut our Sharpies out so that they would not interfere with the robot arm as the code was printing out and it was actually drawing. So we had to cut it, and we used our own handmade caps to prevent any sort of extra or added drawing of the Sharpies. And then those Sharpies were inserted into each little branch that is then turned according to the code that we decided to go with. So here's a description of the design of the 3D printed part, our actual flange. So our paintbrush holder has two main components, the flange adapter and the brush branches. So as I had just discussed, the flange adapter is where it attaches to the ABB robot, and it will be able to compress with a little bit of lenience so that the Sharpie can press into the page. And then the brush branches are where the paintbrushes or the tool pens will actually be inserted into the 3D model for holding. So the adapter is essential for compatibility with the robot using the screw hole that fits the flange to the device. And the branches contain tapered holes that fit standard Sharpie permanent markers at 15-degree angles to the horizontal plane. So our goal here was to make it so that the Sharpies did fit snugly in our 3D print, but didn't fall out as the robot was drawing. And the reason that they're at 15-degree angles with the horizontal is so that each Sharpie drawing on its own, one at a time, won't interfere with another Sharpie that might be touching the paper at the same time. This way, if we orient using code of 30 degrees to the side and then 30 degrees back, we can draw with each pen one at a time with no extra interference that's unwanted. So here we have a little bit of the Cura toolpath and the actual 3D printing of our flange. So the 3D print toolpath was generated through Cura, and a hexagonal pattern with an infill density of 20% was used to print the holder. This is to keep it nice and sturdy, but not use too much print or too much time to actually print the flange, which was a constraint we had to take into account when creating this project. The print took about an hour and 42 minutes to complete. And then once it was taken off, we used a little bit of sandpaper to widen the holes to make sure that the Sharpies would fit in and to make sure everything works well when we actually use it and attach it to the ABB arm physically. I'll now pass it on to Elliot to describe more about the code and the Cura.
All right, so here you can see the toolpaths that we simulated for the robot. We used two separate toolpaths with different programs, so we could just calibrate one pen at a time, run that, and then switch it to the other orientation and draw with the other pen. So that was our main idea there. And so for each program, we set an origin point. It's the same between both programs. And then for the rest of the code, we assigned var1, var2, and var3 to the x, y, and z coordinates of a point on the image relative to that origin point. And then we used the offset with the linear move to move the robot between the points. So here you can see a close-up of some of the code. So there we have the target P10, which is just the origin point. And then there we started with moving it to the origin point so we can calibrate between the programs to make sure that they're going to the same point, because otherwise the two drawings won't fit together as they're supposed to. Here we're assigning var1, var2, and var3 to the different x, y, and z coordinates. And there we have our offset linear move going to those coordinates. And then it's the same for the next program. We're just using P40 instead of P10 there to make sure that the robot doesn't get confused. So when writing the ABB program, we realized that it was quite repetitive and we didn't want to go through and do that for each of the coordinates. So we wrote a Python script to take a text file of the coordinates and translate those coordinates into something that the ABB robot can understand. So on the right there, you can see that we have part of the text file with the coordinates. to the X, Y, and Z coordinates in 3 separate columns. And here you can see a closer look at the Python program that we used. So there we're setting variables to some of the commonly repeated text lines that we have in the ABB program. So you have the linear offset move using your origin point, bar 1, bar 2, and bar 3. You have move P10, which is just moving the robot to that origin point. And then we have the line that sets the variables, bar 1, bar 2, and bar 3 to the X, Y, and Z parts of the coordinate that we're using. So this part of the code is a for loop that we use to take the X, Y, and Z coordinates from the text file, assign those to bar 1, bar 2, and bar 3, and then write the part in the code that will set the coordinates for the ABB robot and has the linear offset move command. Now we'll pass it to Aya, where she can go over some of the issues that we faced.
In theory, the drawing should work perfectly, but we did have some complications. The issues we ran into was we had to cut our Sharpie pens to avoid interactions with the ABB robot arm. Since the pen was a bit long, it was touching the robot. Also, our Sharpie ink dried up quick when we had it pre-cut before. And another issue was the paper was unleveled, which needed adjusting so the Sharpie could be touching it at all times. For future improvements, we could cut our Sharpies right before we do the drawing, or even have a new pen holder design where we could have enough space between the Sharpie holder and the robot so it won't touch when it's not cut. We would also adjust our drawing surface to be equally leveled so the Sharpie presses into it at all times. This is how we designed our chart to keep track of our progress. We have different colors to identify when we have completed something and when we are currently working on it and when the due date is. The green boxes shows when we have completed it, and the blue ones show when we are in progress, when we are currently working on it, and the red ones are the due dates. And now I'm passing it off to Drew to talk about the impact of the robotic painting.
So in our societal impact study, we decided to focus on the impact that robotic painting would have on market expansion of artwork into the middle class. So our interest primarily stems from the fact that art is universally appreciated by all, yet historically, it's only been widely possessed by the upper class and those that can afford it. And as with past trends with such luxuries that are confined to the upper class, with the introduction of automation and other efficient means of manufacturing, there have been increases in supply that result in the lowering of prices to obtainable ranges for most of the consumer population. And we see this as a potential avenue for painting to go with the introduction of robotic artwork. And we believe that this mass production will, in fact, lower the price of physical paintings to an obtainable range that will be reached by most of the middle class. Next. So in this research study, we seek to answer whether or not middle-class consumers will be more willing to consume robotically produced paintings if they are cheaper than normal paintings. As a result, our study centers around the middle-class consumer, meaning that our population studied will consist of members of single-person and multi-person middle-class households. We hypothesize that all middle-class consumer groups that we study will express an increased interest in purchasing robotic artwork. This general increase that we expect to find demonstrates that there is indeed great potential for an expanding consumer art market due to the automation of artwork production. So this research survey that we will conduct is through a one-time quantitative survey. To maintain this quantitative portion, we will use Likert scales to ask our participants the questions we want. And Likert scales, they provide a linear numerical interpolation between two extremes to a response. This will allow us to get numerical data from our participants in order to more easily analyze data. As for the measurables that we wish to gather from our participants, we've divided them into demographic characteristics that we would like to know about our participants, as well as 2 specific measures that will help us come to the conclusion that we hope the survey will result in. So our demographic characteristics will consist of the participant's age, their annual household income, and the household size that they are a part of. This is mostly a furthering measure to our conclusion that will allow us to gauge multiple degrees of responses in accordance to specialized factors that we might want to look at. For example, with these demographic characteristics, we can analyze the differences that generations have on perception of adopting robotic paintings, which will allow us to further analyze and predict market expansion into the middle class. Apart from these demographic characteristics, our 2 specific measures will concern both willingness and participant perception of painting exclusivity. For our first measure concerning the willingness, it concerns the willingness of participants purchasing artwork. And this will be conducted through 2 questions that will assess the change in this willingness. The first question will ask the participant for their previous willingness to purchase paintings, and the second will ask for their current willingness after being introduced to the prospect of robotic painting. The second measure concerning the exclusivity of painting in the eyes of these participants will simply be conducted through a singular question, asking them to rate how confined they believe that painting is currently to the upper class. And these measures in combination will give a general view of the current state of art through the eyes of a middle-class participant, and will give us a means by which we can project the growth of the art market into the future as a result of robotic painting. I will now hand it off to Arpan, who will go through our conclusion and our final remarks.
So in today's presentation, we talked about the assembly and the final drawing in our project. Along with that, we discussed the design of the actual paintbrush holder itself through Inventor, and the 3D printing of the holder, which was done through Cura and using the Ultimaker 3D printers. Along with that, we discussed programming the ABB 140 through the Python code. And then we discussed issues and future improvements, including when to cut the Sharpies and possibly a different design of the holder. And then we talked about the societal impact study of how paintings can be more accessible to middle-class consumers. Next. So to conclude today's presentation, I just want to say that with increasing product demand from all corners of the globe, the future rests in the hands of industrial robots to meet manufacturing and distribution needs. All these processes require intricate and creative programming and design, which is why this course has introduced us to just the basics of the programming and design of these robots and different designs using SolidWorks as well as Inventor. As a group, we found the implementation of the 2 pens to be an interesting concept because it not only provided an extra challenge to our project, but also demonstrated how creativity is needed in robotics in order to expand the bounds of the technology and its usefulness. Thank you.